Okay, hello everyone. We are looking at biosequences and that are being made ready for the next version of Wolfram language. So first thing we have is a page about biological sequences. Biomolecular. How about biomolecular sequences?
Yeah, that definitely sounds better.
Biomolecular. By the way, I hope I don't have to update these pages today because they will have been updated overnight. Is that sufficient?
I think John made various changes today.
Then let's not use this page. Let's do an update first so we don't overwrite those changes. And then, okay, so biomolecular sequence computation, biomolecular sequence computation, something like that.
That sounds good.
Okay, then I'm going to leave you to change the actual title of the page and so on. And but let's go ahead and okay, these pages, boy, lots of. Have you been adjusting all these things like string reverse and so on? Have you been adding links in those pages? Is that what's been going on there?
That's right. Yes.
Okay. Okay. Biomolecular sequence computation.
Singular or plural?
Biomolecular sequences. That's okay. Biomolecular sequences computation. Okay, so this is, well, then you say computation down here, so that won't work, will it? Okay.
Do we want to just keep it generic and have biomolecular sequences? Full stop?
Okay, so I'm going to leave you to change all these things, okay?
Yep.
Molecular sequence representation. Okay, so now should I be looking at these pages like BioSequence and so on?
Yes, please. Yes.
Can we be specific what? Okay, so then BioSequence evaluates what?
No, it's similar to molecule and other functions. Because we have various input forms, so it canonicalizes.
Okay, obviously this is not the right format here, but you'll deal with that, right? Do you understand? That's not the right.
Yeah. The font.
Yeah, same with these things here. Okay, you know, I don't know how many times I have to explain this. The right-hand side here needs to be less than one line long, not multiple sentences. Come on, guys, figure out how to do it. Please.
Certainly.
You know, I mean, just don't do this. You know, I wish people would just not do this and not get it wrong. You put a separate note afterwards that says that. You know, we had this style that we've developed over years, and please, let's not break it for this particular case.
Yep.
Okay, what are the notable things that have changed since last time? And is this mostly the approved design from last time or not?
Yeah, the design is approved. It's the just the documentation.
Okay, so are you asking me to write the documentation, or what's the issue here?
No, just kind of giving you a kit for unfuture writing.
Okay, all right.
And I mean, there's a little bit of discussion about the
Yes.
string pages,
Correct.
which is why
Yeah.
Jeremy and I are here.
Okay, well, let's look at a typical string page, like string reverse.
Right. So question one is, does this really want to be in the main usage, or does it want to be a note in the, in the notes?
In
Right.
the details. I think it should
In
be
the-
in the notes.
Okay.
I think it should be in the notes, just like we say that, something which operates on a list, we also say also operates on sparse arrays and so on.
Yep.
I think it should be that type of note.
Okay.
Okay,
I
good.
can point them to models.
Fine.
And then, some of the pages like string match queue and string take, I think, have an additional note about sort of special behavior that you may want to review.
Take a look at string take. Starting at M. So string take of 10 million will still work, even on a little tiny, what do they call, plasmid thingy? Is that right?
That's it.
Well, I guess that's a question for John, and something I don't quite know the answer to. I mean, will this ever give a longer answer than what's there? Like if you do,
Let's try it. Let's say BioSequence. How do I make a circular DNA string?
Circular DNA.
There's no autocomplete here. That should be fixed. See that?
Yeah, I can
right.
teach them how to do that.
Why is this taking a long time?
That's just loading it once. It should be faster after that.
Okay, so that will do the expected thing. Okay, now if we say string take %151, comma 20. Oh, splatteroo.
That's interesting.
Björn, sorry, wasn't this not the case, John, where we discussed with Isabel that we decided you can't read multiple times around because this is what never happens in biology?
That's right. Yeah, this is only for the case where you reverse 8 and 5, say, for example.
I mean, it's a question, is it a biological operation or is it a mathematical operation?
Yeah. Okay, that's clearly a bad error message, right? You understand?
Yes,
Yes.
we understand this one, yes.
Okay. Now the question is, okay, this question of whether you read multiple times around the circle, I don't know why a ribosome can't just spend its time, hanging out in like a, one of those hamster wheels. Why can't it just go around the hamster wheel many times?
Maybe it can, but according to Isabel, who worked in this field, she said this is not how actually ribosomes read.
Humph. Okay, well, more than I know. All right.
We did discuss this, especially.
Yeah, right. And of course, I mean, the relevance of this node is if you change that 9 to an 8. So you do 8-5 rather than
right. This
5,
is the relevant case.
Takes the wrapped around sequence. Okay, but I don't understand that case. Wouldn't that work? I mean, in other words, if I just take an ordinary string,
that'll give you an empty list or complain. Right? Unless you gave a negative step.
Oh, I see. So this is reverse reading. This is a string take reverse reading. Well, why doesn't it work on a linear DNA sequence?
Right. It's not reversing it.
No.
It's starting at 8, which is the last one, and then continuing forward and wrapping around.
I see.
So it won't let you take something that's longer than the whole circle, but you can start anywhere on the circle and end anywhere else on the circle, which is not something you can do with normal strings because they're not circular.
Seems okay to me. I don't think we're going to get ourselves in trouble with that.
Okay.
All right, what was the other case? String match queue?
Yeah.
Yeah, I think that's the right thing to do. For biosequences with the patterns, make the patterns include the biological, wildcards.
Otherwise, it wouldn't be useful.
Yeah, right. Yeah, seems right to me. Okay.
Yeah, I don't think the behavior is controversial. It's just, making sure that you're okay with this description of it.
And the other question was, do you want the full table here in this function, or is it okay to have the full table somewhere else?
How big is the table? Where is the table?
It's that big it's the first table, which you said wasn't formatted correctly on BioSequence.
This one here.
Yeah.
Yes.
And
But that's not defining.
Yeah, correct.
It's a slightly proper subset of that, right?
So this is built into the BioSequence type entity type, and there's documentation of it on that page.
Okay, no, not good enough. You need to have it here. You need to have it here. You need to say.
Okay,
this
that's
is super confusing. This is super confusing. So what you should say here is, the first thing you should say to not confuse somebody like me, okay, is that DNA, the literals are AGCT. That's correct, isn't it? Right?
Yeah.
That's the literal. Right. Similarly for RNA with a U, AGUT, whatever, AGCTU, right?
Right.
And then give the literals for the peptide. And then say the following wildcard, degenerate or something, ones are also supported. And then I would give the table, which isn't terribly hard. I mean, it just is each one, N is all of them, et cetera, et cetera, et cetera.
Yep. Can do. Absolutely.
Okay. The forms for constructing it. What? That's incomprehensible.
So this is a case. So if you say you want a 5-term DNA sequence,
I'm aware. I'm aware of what it is. Okay. I'm aware of what it is, and you can say that in a note somewhere. But that's not a table. You should give a table. You should give a table of the non-degenerate cases. You should give a table of the degenerate cases. This is a footnote somewhere. I mean, this is what's an example of where you can generate that?
That's BioSequence DNA 5.
Where's that documented?
That's an example.
Listen, guys, how many times do I have to say this? Examples are not documentation. Okay? If there is a form of BioSequence which has a number in it, you must document it at the top here.
Isn't it the second one?
Oh yeah, that's sorry, I misunderstood the question. It's the second one. Usage.
Okay. I would call that (n) to make it less obscure in that actual usage.
You got it?
Yeah.
And I would just say quotes the sequence. If that's a string, just say quotes the string. You see what I'm saying?
Yeah. I mean, I guess I'd been focusing on the string pages. I would have caught this and pointed out that, yes, this is not keeping in our style. I mean, I don't think we would use string. I think we would use like stir or sec.
That is fine.
Yeah.
And is type always a string or not?
No, it can be the entity.
Okay, fine. Okay, chem list should show a list. Are those molecules or what?
Molecules or entities.
Okay, well, so I think you should say chem 1, chem 2, et cetera, et cetera, et cetera. there any reason not to? I mean, it just that way somebody who glances at this can see what's going on.
That makes sense. Yeah, no, that's great.
Okay. Most implied by the sequence? What the heck is that? Come on, what does that even mean?
That given the letters, you can, in most cases, infer what
Right.
it is.
So infers,
Yeah, okay,
attempts
fine.
to infer the type from the sequence, right?
Right.
Is what that should say.
And it should be down at the second element here. This is the second one here should be this should be there.
Really?
It's a very common case. It's going to be the most common case people type in.
You think so? They will not say? I think that it's just a friendliness.
If they type a biosequence, they're going to just type AGCT, whatever it is.
Okay.
And I would put the, go ahead.
Yeah, I think I agree that it's probably more common. Well, I guess it depends on whether you're an expert or not, but I think it's probably more common, at least for non-experts, to just type in the one argument form there than to type in a type and a length.
Yeah, it's very obscure. The length stuff should go way at the end, in my view. And I think those things with genes and proteins, I don't know why you say entity. I would say, oh, that is a horrible thing there. Okay. Infers the type, represents a biological sequence. That is no good. A biological sequence just doesn't cut it.
I thought we changed all biological to biomolecular already per earlier discussion.
Okay.
Right. Well, I guess that raises a question of should this still be called biosequence and not.
Absolutely. Absolutely. It's fine. It's a good shortening.
Okay.
Just like geo is called geo, even though we know it's sort of geographic position, geoposition.
But Stephen, now I think we are getting wrong. The first one is a representation. The second one is not a representation. It evaluates.
Okay. And so this one we say infers the type from the content of the string of the sequence, from the elements that appear in the sequence.
Do we need to be that verbose?
Should
Why
we
not
not
just
use
say it from the sequence?
Should we not use letters? Because elements is yet another technical term.
All right, fine. From the sequence. Something like that. And then what I would say here is biosequence of ent. Gives the bio associated with the specified, with the entity ent, gene or protein entity. Are those the only cases?
For now.
Okay. You can change that one. Those are not the only cases. And then you should say how the entity is specified later.
In the notes.
Right.
Right. And I'm not sure we need the what's currently, I think it's the fourth one, the biosequence of type. I mean, that to me seems like it could be a note. How often are you just going to create an arbitrary one letter?
Yeah, I agree. I think the next thing we should give here is the chemicals. And I think we should do that. And we can, yes, we don't forget the syntax processing stuff. But I mean, that one.
Yeah, well, we'll have it from BioSequence of end, right? So there's already a documented one argument form.
Fair enough. Although, but we need to make sure the autocompletes work correctly for that type thing.
Okay, yeah, that's.
I mean, that is a weird case. I agree. I think that's a weird case. I'm not even certain that I support that case. Okay, let's take a look at what it's doing here. All right, so circular DNA, DNA. Oh, for God's sake, why don't you say DNA or circular DNA? I mean, you know, DNA is much more common, right? Why isn't there circular RNA as well?
There generally isn't circular RNA. It generally doesn't form.
Doesn't exist. Okay. Okay, so let's get it in that order, right? The caption above the sequence in formatted output. What's all this about?
This is for extending BioSequence.
If you make your own ones. We had discussed this in this one meeting.
Okay, you've got to reduce these caption
Yes,
lengths.
yeah,
Absolutely.
we make it shorter.
Yep.
Right. And okay, so no, that's a very obscure thing to say. What you've got to say is something like, if the standard form for BioSequence is type comma sequence. Is that right?
Yeah.
Or the canonical form, maybe?
Canonical form for BioSequence.
Just kind of to be self-consistent, we used exactly the form for molecule that you wrote a year ago. Well, we had exactly this verbiage.
Okay, all right, okay, fine. Well, then we should do whatever molecule does. Should we look up molecule?
Yeah.
Okay, molecule, blah, blah, blah. That's pretty clear, actually.
Right. I think I think where they went wrong is they didn't right. They left out the bracket ... which made it sound quite different from what it was trying to say.
I see. Okay.
I don't know how to fix that, but you guys could do that.
Like we need, if possible, if you put in junk, then it cannot evaluate properly.
Yeah. And also you need to give the quotes SEQ. Now I don't know whether the ... is needed. Is it
no,
needed?
No.
Okay, let's make sure we see all the other ones where we need to see here. So this is, so I assume something like sequence alignment just says.
Well, right now it has a futurized usage, but I think we should follow what we did with. I know this one maybe has a slightly sweeter
I think
case.
this one is worth putting the BioSequence up there,
Mm-hmm.
because BioSequence is a really common case for sequence alignment.
Right.
So I would put it there. I would similarly put it in the case. I would not put it for Hamming distance because I don't will. I don't know. It's probably not harmless for Hamming distance. What do you think? What do you think for these distance measures?
I would think for this ones, yes.
Okay, so by the way, on the pages for distance measures, we should mention something about biosequences on those pages.
You mean on the guide pages?
Yes, about sequences. Okay, about distances rather.
Yeah.
Okay, let's take a look here. BioSequence convert. That is a very strange name. BioSequence convert. I mean, does it usually produce one sequence?
Depends if you have wildcards.
Okay, you know what? This is a really misleading thing to say here. Just say it converts the biological sequence. Does it always produce a list?
Yes.
Is that a good idea?
Yeah, I didn't like it either, but I didn't have a better idea because we cannot have different argument structure to get different result type because it only depends on the presence of wildcards.
Yeah.
I mean, we could have a third argument all and otherwise give only one, but this seemed a little bit strange to me also.
It's strange. Well, hold on a second. Is it strange? How will people use this?
They have a piece of DNA and want to translate it.
Exactly.
And depending on the quality of their PCR, they get it with or without wildcards.
But wait. I'm confused by something. Why are we not translating wildcards? I mean, if you had... Okay, but so why is this exploding things? Those are two different operations. In other words, if you have an N there...
I'm confused.
Okay, if I have a DNA with an N, why doesn't that just turn into an RNA with an N?
Oh, in the case of, transcribe, it does. Yeah, in that case, they map 1-to-1. It's for peptides, the wildcards, and
Okay,
translation
that's
case.
not a good answer because transcribe, what's the difference? Okay, we got three things: convert, transcribe, translate. Those are completely confusing here, right? You got to do better. That's bullshit. I'm sorry. Sequence recognition is not what this is. Okay, sequence recognition is what, some molecule does when it's doing something, right? No.
Yeah, the name is not good. I mean, transcribe and translate, I think, are the terms used in the literature.
I'm well aware. But we got to explain here rather than just saying, I mean, no, that's not what this does, right?
Why not?
So, well, because it converts it to a list of sequences, right? Resolving all...
But it doesn't say to a sequence.
I don't care. It's misleading. Okay, so let's go through what these... Okay,
Yeah,
most of the time, is it transcribe and translate that people are going to use?
I'd say translate is going to be much more frequent
Yeah.
Than what?
than transcribe.
Okay, why isn't it at the top here?
I think they were being alphabetical.
Well, that was a dumb idea.
Yes. Right. So then tell me, what is BioSequence convert and how is it different from both translate and transcribe? Because I think I understand what those do poorly, but I have some understanding of what those are.
I'm sorry, do I want to say inverse or reverse? Because these aren't... Does this operation have an inverse?
Reverse could
Do
be
you understand?
Yeah.
What?
Yeah, reverse is probably better. Yeah.
Okay, so this was a piece of bad thinking, if I might say so. Okay, so now this complement thing is also a very, very, very common operation.
Yeah, we could put that one up top. Yeah.
Complement as in take your A's to G's, etc.
Get the complement of a DNA sequence. A to T, C to G, right? That's what we're talking about, isn't it?
That's right.
Okay, the next thing we want to do is we want to say string reverse because that's the next thing people want to do, right? I would think.
Mm-hmm.
But do we really want to? But
string operations with these other ones.
Yeah, but so that doesn't fit in this group.
No, it doesn't. Okay, all right, fine. but this is completely wrong. String reverse is by far the most important well, yeah, okay, all right.
Okay.
Okay,
Can we
reverse
go back?
complement. No, we're going to put reverse complement in here because that's another thing people do. Reverse and complement a DNA sequence. Okay. Now, here.
Convert.
Right.
So what is this thing actually doing that's different from any of the 4 previous guys?
It explodes wildcards. That's what it does.
Is that true?
It does. It also converts to molecule.
It supersedes. It does more than the earlier ones.
All right.
So, but does it also do the things? Like, does it also translate and transcribe if you give it the right second argument?
That's right.
And
Between biomolecular types, with resolution
Just
by the way, I'd like to put this one above. I'd like to put the RNA above the peptide one, even though it's just logically general conversion. But go ahead.
I'm going to. I mean, maybe this doesn't make biological sense, but from a language design point of view, don't we need a BioSequence expand that expands the wildcards, and then this convert thing can just do, one thing, which is converting?
Well, I would think so. Yeah, I mean, I think that would be better because the convert, what does the convert do? Translate could perfectly well have a destination that is a molecule, yes?
so I thought translation was a specific, like the
It is, but how do you get to a molecule with convert? How does convert, and by the way, it doesn't even document it. It's not even documented. Where's it even documented, what it does? Where's it documented? Where's the list of what the possible types are?
John, didn't we have such a table?
I don't think we ever did. No.
Okay, what are the possible types?
There's DNA, RNA, peptide, a molecule, and if you don't give a type, it just does the expansion.
Okay, so just explain to me, can it be circular DNA?
Not currently.
Okay, but that's something we could imagine. But okay, so molecule is an alternative to peptide, right? By the way, are we really calling it peptide, not protein? I guess protein.
We discussed this the last time, and we came to the conclusion peptide.
Okay, all right, fine. Okay, but so molecule is a translation, is a form of translation, right?
If you say convert DNA to molecule, you end up with a molecule of the DNA. If you say convert, BioSequence convert, and you have a peptide, then it gives the molecule of the peptide.
What? BioSequence convert. Okay, what destination type gives the molecule of peptide?
Molecule.
Okay, so if you have a peptide, you get a peptide molecule. If you have a DNA, you get a DNA molecule. I don't understand why we're not just using, you wrap molecule around the BioSequence and you get the freaking molecule.
There was an earlier design for that. We could do that.
I think that's what we should do.
So if that's the case, aside from the molecule having transcription and translation handled by their own, is there let's see, is the main point of the BioSequence convert the expanding the wildcard?
Yeah, well, we should change its name. It should be called BioSequence expand.
Then we should have two functions. One that just expands and keeps the type, and then we independently convert the types.
But we've got a function that converts the types. It's BioSequence translate.
But it doesn't make all possible crosses.
Well, but so
Which one
first
doesn't it
translate
make?
and then expand.
Which one doesn't it make?
But yet translate only makes peptides. It's biological translation.
It's not translated in the language sense.
Okay, which ones do we need? What are all the crosses? Let's go through those, please. What are they? I mean, you've just told me that there is.
Maybe DNA to RNA.
DNA to RNA. Okay, that is otherwise known as transcribe, isn't it?
Right.
DNA to RNA is transcribe. I
We
think
want-
you're not. Okay, go ahead.
We want RNA to peptide,
Okay, and that's translate.
and we want sometimes peptide to RNase.
That's translate. It just, I'm reading the documentation.
Okay, and so right. So what other possibilities are there that
Molecule.
aren't?
But that's been covered because it's either biosequence of molecule or molecule of biosequence.
But
John, what are all the implemented cases?
I mean,
This is wrong.
wait,
This
wait,
is not properly thought out. Okay, we've got all the cases. You've got DNA, RNA, peptides, and molecules. Okay, and you've also got circular DNA. Those are the only cases that I know of here.
that's right.
Okay, so we've covered all the cases. So convert does nothing except wildcard expansion, so it should have the name expand.
Okay.
Right, and then it makes perfect sense for it to return a singleton list if there are no wildcards.
Exactly.
right.
Exactly. For goodness sake.
No,
Okay.
wait a moment. Is there not a problem still with inverse translation?
BioSequence translate will do the inverse. We would have to.
The question is, listen, guys. The problem is that there are multiple inverse translations, correct?
Exactly.
That's right.
From what to what?
From peptide to DNA. And of course, with wildcards also in the other direction.
Okay, I understand. Peptide to DNA. Okay, so let's be very careful. This says peptides or the reverse. So what does BioSequence translate do when you go peptides to DNA? What does it do right now?
It will give you a list of.
Okay,
all the
what does it do
DNA
for a
translates.
singleton one? What does it do for a single one? Does BioSequence translate always give a list?
It always does.
Yeah.
Well, then we've already solved the problem. From going from peptides to DNA, it gives a list. But going from DNA to peptides, it does not give a list. Is that correct?
Currently, it always gives a list. but
Okay,
it can
that's
be made
wrong.
not to.
That's wrong. So let's not do that. Okay, in the case where it's going, in the rather obscure case.
And okay, so what do you want to do if a wildcard is inside?
Don't expand it. Wildcards go to wildcards. In translate, do not expand the wildcards. Just translate them, wildcard to wildcard.
There's no.
I
There's
don't
no.
think that is possible.
Yeah, the peptide wildcard space doesn't cover the full specificity of combinations. It's more limited.
Well, worst case is you go to an N in the peptide.
Okay, or an X. Yeah, we can do that.
But now, Okay, this is really muddled. So there is a very useful operation, which is the pure expand, which we understand, which resolves wildcards. Oh shoot, definitely not what I want. Expand, make a. Well, really, it's more like BioSequence list, isn't it? BioSequence expand.
Instances.
Yeah, BioSequence instances is the right one. That's the right thing.
We have entity lists, so I think this should be BioSequence list. We
I don't think so, because entity list is more from a class.
Exactly. There's a named class that I feel like this one is different.
Give a list of instances of in which wildcards are resolved. What is this really? This is for give. I mean, this give a list of random instances consistent. Give a list of random instances
Instantiations.
No, because we just say instances. Give a list of all.
I don't think it should. It should be a 2-argument function. Then with the second one, how many?
Okay.
Because it might be astronomically big.
Okay. Give a list of random instances of wildcard resolution or something. I have a bunch of comments on our live stream here. And I'm watching the clock, and I know you have to leave, Michael.
Yeah.
And so, okay.
Do we have any way to make some changes before you proposed now some bigger changes?
Right. Well, let's just have a quick look for other stuff here. I mean,
That's mostly it.
Okay, BioSequence modify. I just want to look at that. And the translate, you're going to have to do that enning. You understand what I'm saying?
Right.
What is this? Please, Michael, just look at these pieces of documentation. These don't follow. Yeah. I mean, I don't know what all this is. Entity representative. What is this? Examples. It's not. But this isn't. This
is not how you write documentation.
Yeah, I don't even know what this is with a space in it. Vertebrate diagram. Where is this? This is entities. Genetic translation table is an entity type, right?
That's right.
Okay, so if I say entity list, genetic translation table. Okay. Why are those capital letters? Is that a standard thing to do in this case? Do you understand what I'm asking? And if I say here, standard name, do we have a standard name? Or am I
canonical name?
Thank you. Really?
Right. Well, the canonical name is always unique.
Yes, I know. But but why aren't we giving these canonical names? Look, how many translation tables do we have? Okay, until we discover life on Europa or something, we don't have a lot of translation tables. Okay?
No, are there not many, John?
There's a lot more than one would think, given all of the archaeal ones.
Okay, is this the number of them? Is this all the translation tables? Yes or no?
This is not probably not all of them. These are only the ones that are really currently categorized.
Okay, fine. One that disappeared in the Precambrian period and we barely know about it, we're not going to worry about for this moment.
Right.
Okay, let me tell you what you should do. Okay, first point, you need canonical names that do not have extra crud in them, right? There's no reason to have extra crud in these names. There are a small number of names. Then what you should do is you should let people put in what is the standard one? What are we?
The canonical name is unique and decided by alpha. I don't think.
I know, but these guys, these guys are making these up, so they can do it right here. They do not need to have extra crud in these names. Okay, so which one are we?
Vertebrate nuclear.
How can there be the invertebrates, the eukaryotes? Isn't it? Am I crazy? Isn't it? Don't all eukaryotes have the same? But eukaryotes are much beyond vertebrates.
It's true. That's to match our mitochondrial.
I know our mitochondria are different, right? I know the mitochondria are different, but this is crazy. Okay, I'm sorry, this is crazy. Look, isn't it the case that all eukaryotes, all prokaryotes have, and that's what people learn in elementary biology, right? Eukaryotes have one form, prokaryotes have one form. Am I right? Am I not right?
I do not know.
I'm not sure I understand the question.
But I'm complaining. This is complete nonsense. It's not just vertebrates. You take your average, amoeba. No, bad example. You take your average, random worm, okay? A sea anemone, okay?
Yeah.
The sea anemone has the same frigging translation table that we do, right? And the sea anemone is not a vertebrate.
Overall, I'm with you. Take the broadest possible coverage instead of trying to match with the mitochondrial name. I can do. Absolutely.
Yes, do that. Okay.
We'll do.
And then okay, so does the sea anemone's mitochondrion have a different translation table than ours?
It might. I think it might. Yeah. Offhand, I don't know, but I'd have to check.
Ali on our live stream is saying that I'm wrong, so I'd like to know what I'm wrong about. So sea anemones, apparently there's an invertebrate mitochondrial and a vertebrate one, and they're different. Okay. But okay, let's do a little bit of biology work here. Ask other people, and let's get the most important thing is that if there is a standard one for eukaryotes, a standard one for prokaryotes, that's kind of what people are going to know. Let me look this up.
Okay, we make some changes and come back.
Well, okay, but Michael, I know you have to go, so
yep.
So list of genetic codes, okay, so this is interesting what Wikipedia does, for example. Okay, which is not completely stupid, the standard code. That's not a completely stupid way to do it.
I agree. We had that at one time. Let's switch back to that.
It's a little bit, us-centric, but, that's...
nature of the business.
I think it requires a little bit more thought, okay? But this is what I would try to do, but... I also think if these are standardized numbers, you should also support those numerical codes.
Oh yeah, we do.
How? I mean, where does it say that?
That's unfortunately the third line in the table where it's to the NCBI index for a
That's
translation
just
table.
wrong. We don't give these as examples, right? We don't give examples. That's not how documentation works. Okay.
I misunderstood. Okay. I will fix this.
Okay. All right. Okay. I mean, this functionality is great, by the way. I'm just, we're dealing with details here, but the details drive me crazy. Okay. BioSequence modify. What does it do?
This is for handling operations that really can't be described fully as string operations that have some biological detail, such as dropping incomplete codons, moving to a start codon, dropping from a stop letter, things that are defined.
Good. Yeah, those are useful things. But is modify, just like we have molecule modify, is that really the right kind of way to describe? Is modify the right kind of thing? Because this is a sequence to sequence transformation. I guess it's right. I mean, I guess that's consistent with what we're doing with molecule, which is a molecule to molecule transformation.
I'd say that's right.
Drop to start codon. Okay. Look, I think Michael has to go. I'd like to comment on some things on the live stream, but if Michael needs to go, he should drop.
I think
Michael went ahead and dropped. Yeah.
Okay. All right. So this isn't right either. This is not right. Okay. Let's go back here. All right. Generate a list of instances in which wildcards are. Generate a list of random instances.
Is random instance giving based on wildcards?
Yes, because if it wasn't for wildcards, random instance would give same. You see what I'm saying?
Okay. Not sure why then if we have BioSequence instances, why do we need random instance, right? Isn't that just
no? It's different. No, because this can be very long. BioSequence instances could be very, if you say n means anything, right?
Okay.
Give me another famous wild card.
S.
Okay. What the hell is, sorry, what, I'm sorry. What does it mean, Unicode characters? Why are we counting Unicode characters? They're just ASCII, right?
For the extended sequence types, it's really handy for transfer RNA for folks to use kind of Greek letters and such things.
So what?
Oh, yeah.
I mean, that's a detail, right?
Sure. Yeah.
actually, what we would have to do to be consistent, this is that's what we should do, just like we do for geo.
Mhm.
Has to have a delimiter there. What the heck is computation here? No, generate all subsequences of a given sequence. Is that right?
Oh, yeah, that's better.
But is it all, in fact, or is it? No.
Write the specified subsequences. Maybe. Oh.
Well, you know, it's sufficient to say all because that gives the idea of what's going on.
Mhm.
Oh my gosh. Ali is saying there are exceptions even in the vertebrate mitochondrial code. Okay. All right, but I'm sorry, let's keep going with this. I'm looking up here and I'm concerned that where's string match Q?
It's right near
Okay,
string.
okay, all right. Find positions of substrings. Find positions of substrings Okay. Where is that one? BioSequence. Let's see, start codons. Are you sure that, are we going to have more things in BioSequence modifier? Or is it actually in the end going to be only about codons and start codons and things like that?
Yeah, this is going to be our primary way to modify secondary structure.
Okay. What? What? That's not true. There are proteins whose physiological function is not known. Aren't there? I mean, why would it necessarily be known?
That's a great point. Yeah.
Okay.
But all the, I mean, the entities that we have, right? Those are.
Yeah. Biological sequence entities. BioSequence entities.
And we probably have proteins that still extend beyond that. So
Okay, all right. BioSequence entities. Known human and other genes. Known human and other proteins. Is it the alphabet or is it what's a type? Is the type an alphabet? I hardly think so.
the type includes all of the letters that are allowed, all of the degeneracy
Well,
rules.
then don't say alphabets.
Yeah, I was going to say I don't understand that title.
Okay, so hold on. It's BioSequence entities. This is basically telling you base biological organisms or something. What are those things called? I mean, well, this is basically genetic code information.
And then codes to the alphabets, maybe.
But it isn't just genetic. It's BioSequence type.
Yeah, it's genes, it's proteins. It's
Okay, molecular. Okay, what is this? DNA, RNA, peptide ... right?
That's right.
Okay. Okay. All right. What else here? Okay, I'm going to need to go in a minute here. So, let me just read through our comments on the live stream. Ali is commenting, are we going to have a session on red mine issues? I certainly hope so. I asked for one. Bug tracker marks some critical issues as resolved when they clearly have not been. Well, I've asked for such a session, so I'm hoping it's going to happen soon. Maybe somebody who's an organizing person here can tell me when that's going to happen. I could go look on my calendar and see whether it's scheduled here. Well, I don't know where it is. Yeah, I don't know where it is. Why isn't it scheduled? I don't know.
Well, I don't think
Do I
there's
need to
anyone
send a
here.
message?
I don't think there's anybody. Well, maybe Brady, but I don't think there's anybody here who can answer that question. I can't speak to the point. I mean, I don't know specifically which issues Ali is referring to, but I think in general, we mark things as resolved when they're fixed in our internal build, which may not necessarily mean
Right.
it's actually in the
that's an
download
important
you
point.
see.
Right. Okay, Brian is commenting. Cyclonucleic acid forms are used in lab to amplify nucleic acid. Standard mRNA is linear. Viral RNA can be circular. Yes, indeed. Right. If you use a strand displacing polymerase, it can bump off the existing preceding copy. Okay. So he's suggesting an option permits circular read-through. Okay, we need some more biology information here. You know what? I have heard of this phenomenon of if you use a strand displacing polymerase, it can bump off the existing preceding copy. Okay, so we better go find out about that. So that's going to inform whether string take. Boy, well, there's a question of whether string take can do the circular thing, which probably it should, but there's a question of whether this needs to. I don't think you can like generate a long repeating sequence this way. Question from Ethan: what's the future of this? Ethan says, I do drug discovery. You're planning to work on machine learned potentials, docking, HTTP screening. That's probably more of a Jason question. I don't know the answer. I mean, I know we have a whole bunch of things coming in the area of additional molecular geometry kinds of things. Ethan is saying I need access to small molecule databases, which I think we kind of have a small molecule database. But I don't know whether you have as big a small molecule database. It depends whether that's proprietary databases. So on potential ligands, steered molecular dynamics, and so on.
I mean, we have the chemical entities, but there's also very easy access to PubChem, which is the largest small molecule database.
But I don't know the bindings, compute binding free energy for molecular dynamics. I mean, we are just starting to work on molecular dynamics kinds of things. Ali is asking, were there bioinformatics people involved? Yes, there absolutely were bioinformatics people involved in this design. In fact, the fact that there aren't any today because we're down to sort of the end of the line, or we think we are. Ethan was commenting that some stuff in BioSequence is out of lexicographic order. Should look at that. If we want it in lexicographic order, it's not completely clear what it is. Ethan is commenting, by version 13, we should be able to net train on standard data sets for learning protein structure. Yes, we would like to. I don't know what the status of these things. I mean, I don't know what the status of net encoders and so on for biosequences is. Can anybody comment on that?
It's not bad. Our friend Mohammed has some good work here.
Okay, have you been talking to him?
Very, very sparsely until we can get the basics off the ground, but will be a good time to circle back.
Okay, fine. I noticed you just moved to a new university with a much fancier position, so all good. There. Okay. Let's see. Valerie. Now I'm showing off the fact that I can just about transliterate Cyrillic here. They're even, assuming I didn't get that wrong, apologies if I did. There are even DNA parts that can encode multiple proteins or even multiple RNAs simultaneously. Wait a minute, this is different reading frame type things, and where I'm somewhat confused by that.
She might be referring to the case of selenocysteine and pyrrosine, which, depending on chemicals that are kind of around the environment, it changes the way that the translation is interpreted. There's an example that we have in Translate of modifying one of the translation tables to capture these effects.
Okay. All right. I have to go. I think we're basically done here. I wouldn't mind seeing this one last time, but this is looking good. Lots of wonderful functionality.
Great. Is there anything we should expose, or leave it all futurized until the next review?
No. Put everything out there. It's all
Great.
good to go. But please fix the actual documentation, stylistic issues, and so on.
Absolutely.
Okay, sounds good. All right. Thanks to folks here. Thanks to guys on the live